Welcome back to part 2 of the lecture on split phase motors. We're going to be getting right back into motor power consumption. We were talking about watts and 240 volts versus 120 volts. At the bottom of the slide, which is where we left off, you'll notice that it says a 240 volt connection is generally preferred, and this comes down to amps. It always comes down to amps, and it comes down to being able to pull smaller wires over longer distances. You see, with lower voltage, if the wire is very long, if there's a lot of work to do on the other end of it, you may have a voltage drop at the load that is enough that can cause problems. So by increasing the voltage, you transmit better from place to place, and you keep the amps lower. Everybody would rather pull number 12 or 14 wire than they would number 6 or 8. It's just got to do with size, it's got to do with money, it's got to do with convenience. All around, the higher you can get the voltage for something you're running, the better. Now, we're not going to be setting up houses for something different than 240 volts, so generally speaking, you're going to get what you get when you get there. But it's good to know why they do certain things and how you can better take advantage of it, especially when it comes to sizing a motor, or if you're starting a new application, maybe a ventilation fan, something like that. It's something to consider when choosing what motor you'd like to buy. Okay, there we go. Sorry, my slideshow was acting up. I am very new at this. Okay, so now we're going to step into the real workhorse of the American HVAC industry, in my opinion. This is the permanent split capacitor motor. All of you have dealt with one of these in some way or another in your life, even if you don't realize it, just because you probably have an air conditioner at your home. If not, you probably have a furnace at your home. You have something that uses a permanent split capacitor motor. These are very common in condenser fans. They are very common in blower fans. Though on the blower fan side, we are starting to phase them out for another motor we will discuss later in the semester. The permanent split capacitor motor, though, is an excellent motor. You have very good starting torque. They run well. If the capacitor is kept within tolerances, it will be a good, solid, reliable motor for a very long time. These motors do start to have problems, though, when you let your run capacitors get weak. You'll start to have improper phasing. They won't want to start. You'll have high amp draw. When they do run, it could seem weak. It is very important to keep the run capacitor on these motors in good condition. Some permanent split capacitor motors also will use a start capacitor, feeding the start winding as well. This is just to give them extra starting torque. They're then removed from the circuit at ding 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 75% of run speed, just like the other motors we discussed earlier in the lecture. This can be achieved by a centrifugal switch, but generally speaking, it is done with a potential relay, and a potential relay just senses voltage and a voltage differential. When the motor gets up to running speed, it will sense this, it will open the contacts, the start capacitor will be removed from the circuit, and it will just run on the run windings and the run capacitor feeding the start windings. Very simple system, very easy to use, and like I said before, generally speaking, very reliable if you keep the capacitors in good condition. Most of these capacitors these days are the AC oil-filled type. You used to have PCB capacitors. You may run into one in the field. If you do, and it's not damaged, you might want to hang on to it. It's like a piece for a museum now. They were very popular for a long time, but they were phased out because the PCBs were giving people like you and me leukemia and things like that. So they went for a safer option with the oil-filled. That said, the capacitors of today are not like the capacitors of yesterday. I have seen PCB capacitors that were 40 plus years old and still tested perfect, and I have seen lots of these new oil-filled types that were weak within a couple weeks of being put in, or came to me weak, or died very quickly. It is not the same game anymore. It's unfortunate, but it's the world we live in. They made it safer. Let's talk about identifying the capacitor terminals really quick. And quick note up front about this. On a lot of modern run capacitors, they will no longer be marked like this. I guess they've changed the way they make them inside, or they've figured out that it didn't make that big of a difference. The textbook says if you hook it up backwards, you're likely to have a short circuit that could do a lot of damage to the start winding of the motor. I don't dispute this at all. It is 100% true. But a lot of capacitors you buy from the store today do not come with a mark, or if they do, they're not very readily seen. That said, if you do see a mark, please follow the marking instructions and make your motor live a little longer. So on the capacitor in the picture here, you'll notice an arrow going from left to right and a dash. Let me find this in the book so I don't tell you wrong. One terminal is identified with an arrow, a painted dot, or a stamping a dash in the capacitor can. The identified terminal will mark the connection to the plate that is located near to the metal container or can. It has long been known that when a capacitor's dielectric breaks down and permits a short circuit to ground, it is most often the plate nearer to the outside case that becomes grounded. So, like I was talking about before, but this sounds a lot better. For this reason, it is desirable to connect the identified capacitor terminal to the line side instead of the motor start winding. That's a term I haven't used in this lecture, but I have used it, and I emphasize you need to remember it. Line side and load side. Line side is the portion that has power going in. Load side is the portion that has power coming out and is going to your load. So if you're talking about a relay, the line side would be terminal 1. Load side would be terminal 4 or 3. No, 4 or 5. Doesn't matter. Either way, power in is your line. And remember those terms. That's how we talk in the industry. You need to catch up with it if you're not already doing it. So looking at the picture on the top right, we can see two circuit breakers. This is a 240 volt motor. We have our run winding, our common winding, and our start winding. You'll notice L1 is connected to the run winding, but it also goes to the run capacitor and hits the start winding. L2 goes to common. So you'll notice power gets fed on L1 and it goes to 2 windings, and then common is its path home, or vice versa if that's how you want to look at it. But remember, with alternating current, it alternates. It's going in both directions all the time, 60 times per second, faster than we can think or see or do anything. So common winding is the path home. The other 2 windings do the work. Let's keep that in mind as to how this all gets wired up. In the second picture, you can see the identified capacitor terminal connected to the line. And this, remember, that's the electrical signal symbol for a capacitor, and it shows you the direction the capacitor should be going. That would indicate the slash part being your dash or your arrow or something like that. And that concludes the lesson on split phase motors. I hope this was enjoyable or somewhat informative. Like I said in the information put on Blackboard, please give me some feedback on how these videos are working out. I know it moved fast. I don't really get to draw on the board and do all the things that I normally do during a lesson. It's hard for me to keep my thoughts together. I'm hoping that we're not going to have to do this for very long. If we do, though, I promise you I will get better. But criticism from your end would be very helpful for doing that. Hopefully I can figure out a way to start drawing on some of these or doing something a little different so I can show more, so that I can make some points that I would have made with the whiteboard. We'll be getting into shaded pole motors next week if we don't meet. If we do meet in person, we're going to be doing a bunch of lab work. We need to discuss voltage potential differences and how that works. If you have any questions, please contact me via email. Short term, be checking your student email on a regular basis just until we know what's going on and what the plan is. And I'd suggest doing that for the rest of the semester anyway, seeing that this could change week to week, day to day. We just don't know how it's going to go. I know there's a strange clicking noise in the background of the videos. I'm not sure what that is. Right now it's my dogs walking into the room, but I heard it in the other recording. I can't figure out what that is, so if anybody knows, please let me know. Otherwise, thank you. If you have any questions, feel free to reach out. Have a good evening.